This PowerPoint has been put together to help you understand what terminal velocity is. It follows on from some of the previous lessons we've had on motion and unbalanced forces, and how a resultant force will affect the acceleration of an object. So if you're not happy with that, you maybe need to go back and revise those topics first before going through this. What I want you to get from this is, first of all, to be able to state what terminal velocity is, understand what those words mean. I want you to be able to describe how changing forces will affect the motion of the object, how it makes it maybe speed up, slow down, or even fall at a steady pace. And finally, I want you to know how a velocity time graph can illustrate an object accelerating up to or decelerating down to a terminal velocity. So I've got some pretty straightforward animations here, which will consider somebody that has just jumped out of an aeroplane. At the instant a person jumps out of an aeroplane, there's only one force acting on them, and it's the same as any object within the Earth's gravitational field, and that's their weight. It's the force caused by gravity. If you look at this picture, you can see there's an unbalanced force. A large force is acting downwards on this body, which means this person is going to accelerate. As this person accelerates, they're going to start moving through the air, and their body is going to collide with the air particles, each of which is going to provide a little bit of force. The faster this person falls, the more particles they'll hit. The more particles they'll hit, the more force they'll experience trying to slow them down or to slow their acceleration down. So what you can see here is, as this person is accelerating, a force is increasing, which is trying to resist their motion, which is slowing their acceleration. And this will continue until this point, where both the force acting downwards and the force acting upwards are equal. Force acting downwards is weight, force acting upwards is air resistance. Because they are both equal but opposite, the resultant force on this body will be 0 newtons, which means there will be no acceleration. This person will then be falling at a terminal velocity, and for a skydiver it's about 130 miles per hour, which is pretty fast. Certainly don't want to be hitting the ground at that speed. To prevent that happening, a skydiver will open a parachute. The result of this is a large surface area, meaning more collisions with more air particles and a massive increase in the force trying to oppose the motion of this object. Now you can see that because it's a greater force acting to slow the skydiver down, and it's much bigger than the force trying to speed the skydiver up, this skydiver is going to decelerate. Because air resistance is relative to the speed at which somebody's moving, as this person slows down, the air resistance is going to get smaller, and it'll continue getting smaller till we get back to this point where the force trying to make the person speed up is equal but opposite to the force trying to slow this person down. So again, a resultant force of 0, no acceleration, so this person is falling at a constant speed. So again, a slower second terminal velocity. And the skydiver will continue to fall at this speed until they reach the ground and come to a stop. This final slide shows us the velocity time graph of the skydiver. We have time going across the x-axis and we have velocity on the y-axis. Remember, velocity is speed in a given direction. Now, starting from 0 seconds, you can see that the velocity increases at a rapid rate, so it's got quite a large acceleration. This is shown by the steep gradient of the graph. This person continues to accelerate until they reach a constant speed after about 40 seconds. Now, the acceleration isn't constant at that point. You can see that the gradient gradually decreases to 0. This means that even though the speed's still increasing, the rate at which it's increasing is getting less. Now, this is because the resultant force acting on the skydiver is less. The weight is always the same, that's a constant, but the air resistance increases as velocity increases, which gives us that curved shape. So quite a steep gradient to start with, curving off to become flat. Now the flat bit, the horizontal bit, on a velocity time graph is showing as a constant velocity. This skydiver's constant velocity, or their terminal velocity, will stay at about 58-59 meters per second until about 60 seconds time. At 60 seconds time, you see there's a rapid decrease in velocity. Again, a steep gradient, but this time going down, which is showing us the person is slowing down. This is happening because the person has pulled their parachute. They get this massive force acting to slow them down, opposing the weight, which means the resultant force is acting against the velocity, which is slowing that person down. And they'll slow down again until the line becomes horizontal, at which they'll fall at another slower terminal velocity. You can see you've got the same shape of the graph, a gradual change from a rapid decrease in velocity to a gradual decrease in velocity to falling at a steady pace. And finally, at about 210 seconds, you can see the line suddenly drops to 0, which is representing the point at which the person will land on the ground and come to a complete stop. Now, the reason the graph has this distinctive curved shape from a rapid change in velocity to a constant speed is that the change in motion is happening through a fluid, so there's a gradual increase or decrease in air resistance. You would get a similar shape for any object accelerating or decelerating in a fluid, and a fluid is anything that flows, so a liquid or a gas. So, the terminal velocity of an object is the maximum velocity reached by an object as it falls through a fluid, and air is the most common example, which is applied to a skydiver. It occurs because the driving force and the resistive force are equal but opposite. In the case of the skydiver, the driving force is weight caused by gravity, and the resistive force is air resistance. Other examples could be the thrust of a plane being opposed by air resistance, or the thrust of a boat, or even a fish moving through water. The velocity time graph of an object approaching a terminal velocity has a distinctive curved shape. This is caused by a rapid change in velocity where there is a large resultant force due to a large driving force initially and no resistive force. The acceleration will gradually decrease as the resistive force increases with velocity, and the object will eventually fall at its terminal velocity, which is shown on your velocity time graph by a horizontal line. You could be asked to consider an object accelerating to a terminal velocity, or in the case of the skydiver, decelerating to a slower terminal velocity.